Let's go on and look at the roots of a complex number. And so, if you've been given, say, the square root of 4, we know that it is equal to 2. The square root, let's say the cube root of 8, this is equal to 2. Of course, we know this is positive or negative. And then we have got the fourth root of 16. We know it is either positive or negative 2. We can go on and on. Now, let's say if we have got the nth root of b, this maybe is giving us c. So you can also just write this as nth root of b. So nth root of b is what? Is c. So what this means is if you have got nth root of b giving you c, then if you get this c, you raise to the power n, you should be able to find b. Just like here, if the fourth root of 16 is giving you 2, that means 2 to the power 4 is supposed to give you 16. If the third root of 8 is giving you 2, then 2 to the power 3 is supposed to give you 8. If the second root or the square root of 4 is giving you 2, then 2 to the power 2 is supposed to give you 4. So if the nth root of b is giving you c, then c to the power n is supposed to give you b. So this is important to understand. Well, now how do you find the nth root of a number, a complex number? So basically, when you find the nth root of a complex number, the simplest way is take it into polar form. So nth root is given by, we know that a complex number exists in the form r cos theta plus I sin theta. So all you do is you are going to get the nth root of this r first. So that will be nth root of r, and then cos. Now to the angle theta, we're going to add 3 sixty k. So 3 sixty k plus theta, and then divide it by n. And then also to the other angle there, that will be I sine. So that will be 3 sixty k plus theta, and also divided by n. So this is when we are dealing with radians, but if you are working, this is for degrees, that's why we're adding 3 sixty k. But when we are working in radians, that will give you n root of r. So we're going to have cos 3 sixty is the same as 2 pi. So that will be 2 pi k plus theta divided by n, and then plus I sine 2 pi k plus theta divided by n. So this is how we work with this. Now this k we are seeing depends on the value of n. So k starts from 0. It's a positive integer which ends to n minus 1. So if we are talking of the nth root, it is going to end there. Now say we are talking of the square root. Square root, that means n is equal to 2. So then k is just going to be 0 and 1. If you are talking of the third root or the cube root, then k is going to be equal to 0, 1, and 2. If you are talking of the fourth root, then we are going to end at 3. Now let's go over some questions regarding roots of complex numbers. Okay, we have got this problem. Show that 1 over 2 plus root 3 over 2i is the sixth root of 1. Now we said if 2 is the fourth root of 16, then 2 to the power 4 is supposed to give us 16. So if you have got this as a sixth root of 1, then if we get this raised to the power 6, it's supposed to give us what? A 1. So that is basically what we're talking about. And so to work out this problem, what we are going to do is we are going to convert this into polar form, and then we raise it to the power 6. Okay, so that is going to give us the first thing we want to find is theta, the angle. So theta is going to give us, is given by tan inverse of y over x. Now y here represents the part which has got I, the complex part or the imaginary part, that is root 3 over 2. Now we are dividing by x, and x here is 1 over 2. Well, this is going to give us tan inverse. If we take this to be multiplication, then the 2 is going to go on top, and that will give us root 3. Now tan inverse of root 3 is pi over 3. That is 60 degrees. Now the next thing that we want to find is r, and r is given by, you get the first portion here, square it, get this portion, square it, and then square root. That is 1 over 2 squared, and then plus the root of 3 over 2 also squared, and then we square root that. Now 1 over 2 squared will give us 1 over 4. Root of 3 squared will give us a 3. 2 squared will give us a 4. So since we have got same bases, just add, we got same denominators, just add the numerator. So 1 plus a 3 will be what? A 4. That will be 4 over 4, which is a 1, and the root of 1 is a 1. So that will be it. And now at this point we can express that one in polar form. Polar form we write in the form r cos theta plus I sin theta. Well, this should be inside. So our r, we found that it is 1, so we can just leave it out. 1 doesn't affect anything, and so that would be cos theta, we have found pi over 3, and then plus I sin pi over 3. Okay, so we are saying if this is the nth sixth root of 1, that means this number to the power 6 is supposed to give us a 1. So get this and then say to the power 6, is it equal to a 1? If it is equal to a 1, then that is true, we've shown. Now if you've got something raised to a power like that, a complex number raised to a power, all you take is cos, that power comes here, it multiplies with the angle, and then plus I sin, the power comes here, it multiplies with the angle. So this will give us cos 6 times pi over 3, that will give us 2 pi, and then plus I sin 2 pi. Of course, cos 2 pi, we know 2 pi is 360 degrees. Cos 360 degrees is a 1, and then plus I. Now sin 360 degrees is a 0. So 0 times I is a 0. 0 plus 1 is a 1. So this we have what? We have shown. Okay. So that is how we can go a bit with that one. Let's consider another problem. Let's say let's find the cube root of 8i. Okay, first let's start by just finding the cube root of 8. We know that from, if we just take this as a real number, cube root of 8, we just say that we put 8 there, and this is going to give us what? Cube root of 8 is a 2. We forget. Well, let's go with complex numbers. We find this cube root. So what to be it. So the first thing is we want to write this 8 in polar form because this is a complex number. So z here is equal to 8. That means it doesn't have any imaginary root. The imaginary part is 0, so this is 0i. That is the meaning. And so we want to find the angle theta first. So theta is given by tan inverse y over x. Now y, the imaginary part is 0 over 8. Tan inverse of 0 or 0 over 8 is a 0. Tan inverse of 0 is 0 degrees or radians, doesn't matter which one we are working with. Okay, now let's go to finding r. R is given by, you get just this and this, you square them. Of course don't get the I, just get a number in front of I. Now that will be 0 squared and then you square root. So r is simply equal to 8. So that means the complex number 8 is the same as r is 8. Okay, and then cos the angle theta is 0 radians plus I sin 0 radians again. Okay, now I want to take the cube root. Remember when I'm talking the cube root or the nth root, what you do is nth root, we know that is given by n root of r, open brackets, we have got cos 2 pi k, so that is 2 pi k plus theta divided by n, this is the n here, and then plus I sin 2 pi k again plus theta divided by n. So that is how we take the nth root. And so for here we're taking the cube root. So the cube root, we are going to take cube root of what? Of 8. Okay, and then we'll say cos. Now to the angle 0 we are adding 2 pi. Now adding 2 pi k to 0 is simply adding 2 pi k and then divided by what? N. N is what? We are taking the third root, the cube root, so n is the 3, and then plus I sin, even this side it was going to be 2 pi k divided by 3. Okay, now k differs. K starts from 0 to n minus 1. So in this case, because we are talking about the third root, it is going to end at 2. Okay, so that is going to be it. So we'll start when k is equal to 0. What will be the cube root? Of course, cube root of 8 there is a 2. So outside here we have got a 2, and then inside is going to be cos. Now this is going to be a 0, so that is going to give us what? 0 times anything is 0, and 0 over 3, that will still give us a 0. So that will be cos 0 plus I sin 0, and we know that cos 0 is a 1, sin 0 is 0, so that is going to give us a 2. This is the first one. What of when k is equal to 1? So when k is equal to 1, this is going to be 2, open brackets, cos. So where there is k, let's put a 1. So that will be 2 pi over 3. And then plus I sin 2 pi over 3. Now this 2 pi over 3 we are talking about is 120 degrees. So cos 120 degrees supposed to give us negative half. So this is giving 2 negative 1 over 2. Okay, plus we have got I. Now sine 120, which is sine 2 pi over 3, is root 3 over 2. So that will be it there. Now we are multiplying with a 2 which is outside here. So this is going to give us 2 times negative half is negative 1. 2 times the other portion, the 2 are going to cancel. That will be root 3i. So this will be the value then. Now we go to the other one. When k is equal to the last one, when k is equal to 1. I mean when k is equal to 2, we've already found for 1. When k is equal to 2, this is going to be equal to the third root of 8, of course, is a 2. That will be open brackets, cos. So put a 2 here to be 2 times 2, which will be 4 pi. So it will give us 4 pi over 3 plus I sine 4 pi over 3. So this is going to give us 2. Now cos 4 pi over 3. 3 into 180 is 60 times 4. That is about 240. So cos 240, if I'm not mistaken with the conversion, that is supposed to give us negative 1 over 2. And then sine 4 pi over 3 supposed to give us negative root 3 over 2. But remember there is an I there. So if we multiply with a 2 which is outside, so that is going to give us negative 1 minus root 3i. So these are the three values for the cube root of 8. The first one is 2, and then we have got negative 1 plus 3 root 3i, and then we have got negative 1 minus 3i. So basically that is how we find a root of a complex number. Well, I can leave you with finding using this procedure in complex form. So find the cube root of, let's have been just given to find the cube root. Okay, let me leave a very simple example of a square root. Find the square root of 2i. So we can try out this. Let me say not 2i so that it will be much simple for us to work with. Say 1 minus 2i. So we can go on and try out this problem. Okay, that is still anyway 1 minus 2i. So if we are able to find the answer, let me know in the comment section, and if something was needed to be done or some clarity is needed, you can share in the comment section so that you'll be able to help each other. Stay blessed.